Yeah, so good morning, my viewers. This is another lesson that we are going to cover Form 2 Mathematics. Form 2 Mathematics. And the topic is equation of straight line. Equation of straight lines. We are going to cover a Kcse question. Kcse 2015 Paper 1. This is a 10 marks question. I want to explain this question. I want to make it very easy so that our students who is in Form 2 or our students who is in Form 3 or Form 4, when he is revising, when he follows this channel, he is able to understand this concept very well. So you see the concept that the examiner tested in this case. So this is what I want us to do. So let's go through the question together. So welcome to Mwalimu Ignatius Wahome YouTube channel. Enjoy this lesson. Karibu sana. Now, so this is the question. You already given the question here. Now, a straight line R1, line R1, whose equation is 3y minus 2x equals minus 2, meets the x-axis at R. Meets the x-axis at R. Determine the coordinates of R. 3 marks. Determine the coordinates of R. Then we go to question 2. A second line R2 is perpendicular to R1 at R. So you must understand how to get the coordinates R. For it, proceed with this part B. Find the equation of R2 in the form of y equals to mx plus c. The form y is equals to mx plus c is called the gradient intercept form. The gradient intercept form of finding the equation of a straight line. Then the third one. A third line R3 passes through negative 1 and parallel to R1. Parallel to the first line. Parallel lines. Concept of parallel lines. Perpendicular is tested there. Then the last question is the coordinates of S at which L3 intersects L2, where L3 intersects L2. So see the question. So you can see that question. So now I want us to start this question. Now let's start. Now a straight line R1. This is our R1 is 3y minus 2x is equals to negative 2. So the examiner tells you this. Cuts x-axis. Cuts x-axis at R. Cuts x-axis at R. Find the coordinates of R. So where the graph cuts x-axis, at x-axis, the value of y is always equals to 0. So at x-axis, y equals to 0. Y equals to 0. So you go back to your equation. There's 3y minus 2x is equals to minus 2. X is equal, y, the value of y equals to 0. Where the graph cuts x-axis. The equation of the x-axis is y equals to 0. So substitute y here you put 0. 3 bracket 0 minus 2x is equal to minus 2. Equals to minus 2. So therefore, they become 0. Minus 2x equals to minus 2. Our x, divide both sides by minus 2, by minus 2. You get that our x is equals to 1. Our x is equal to 1. Our value of x is equals to 1. So therefore, what's the coordinate of R? R is xy. 1, 0. 1, 0. And that's the answer. For A, we have already answered the first question. Determine the coordinates of R. Determine the coordinates of R. Determine the coordinates of R. And the coordinates of R mean 1, 0. So therefore, in this case, you only need to understand at x-axis, y is 0. If it was at y-axis, meets y-axis, the value of x would be 0. But the examiner is saying at x-axis, the value of y equals to 0. You just substitute and get the coordinates of R. So you already have the coordinates of R. So go to question 2. which is part B of our question. Part B of our question. A second line L2. Now L2 is perpendicular to L1. L2 perpendicular to L1. Perpendicular to L1 at R. You can see at R, where R is 1, 0. Where R is 1, 0. So you must get the value of R, the R correctly, for you to proceed. So this concept, the examiner is testing here. He wants to know that if the student knows how to deal with that, the product of the gradient of two perpendicular lines should be equal to -1. So as we say, M1 times M2 is equal to -1. In this case, in this form, y equals to mx, m represents the gradient. M represents the gradient. So therefore, gradient of the first line and the gradient of the second line should be equal to -1. So let's see how do you get the gradient of the first line. Let's see how do you get the gradient of the first line. 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 So R1, our R1 here, our R1 is 3y minus 2x equals to -2. Is equals to -2. Is equals to -2. So can you write this equation in form of y equals to mx plus c? So take this on this side, -2y, you get 3y is equal to 2x minus 2. We want us to write it in this form so that we can identify the gradient. The gradient. So divide by 3, divide by 3, divide by 3. So therefore, y is equals to 2 over 3x minus 2 over 3. This is R1. That is R1. That's the equation R1. So therefore, R1. Identify the gradient now. There is a gradient M1. We go to this concept that we said M1 times M2 equals -1. M1 times M2 equals -1. So our M1 is 2 over 3. So 2 over 3 times M2 is equal to -1. So therefore, multiply both sides by 3 over 2 times 3 over 2. Divide this and this is in this. So our M2 here is equals to -3 over 2. Our M2 there is -3 over 2. That's M2, the gradient. So therefore, we already have the gradient, and now we have the point of R2 now. R2 passes through R2. So R2 passes through R. It passes through R, which is 1, 0, passes through R, and is perpendicular. So our M2 we have got is -3 over 2. Where M2 in this case represents what? The gradient. Represent the gradient. So we are told to write it in the form of y equals to mx plus c. Y equals to mx plus c. So let's see how to get the equation of L2. L2 now. Y minus, so you want to find the equation is say change in y over change in x equal to the gradient. Y minus 0 all over x minus 1 is equals to -3 over 2. Equals to -3 over 2. So therefore, for you to get the equation in the form of y equals to mx, you multiply both sides by the x minus 1 by x minus 1 to remove this denominator there. So you get y minus 0 is equal to -3 over 2x. -3 over 2x times -1, that is plus 3 over 2. Plus 3 over 2. You write like that. So this is, then y minus 0 is 0. So there, this is y minus 0 is y. So therefore, y is equals to -3 over 2x plus 3 over 2. And this is the L2. That's equation of L2. That's equation L2. So we already have L1. This is our L1. This is our L2. That's L2. So we have done A and B now. I want us to go to C. So note that L1 and L2 they are like that. Other line L3 passes through negative 4, 1 and parallel to L1. Find the equation of L3. Find the equation of L3. Find the equation of L3. Find the equation of L3 now. So let's see. You have this L1. L1 is y is equals to 2 over 3x minus 2 over 3. In this case, when you talk of parallel lines, we say the gradients are equal. M1 is equal to M2. In this case, M represents the gradient. M represents the gradient in this question. So therefore, because it's parallel, gradient of parallel lines are always equal. So therefore, take the gradient of the L1, which is 2 over 3. The gradient is 2 over 3. So take 2 over 3. That is M1 is equal to M2, which is equal to 2 over 3. Then take the point given, minus 4, 1. And then take an arbitrary point, xy, a point on that straight line for you to find the equation. So therefore, the gradient is 2 over 3. Because it's the gradient of L1, it is also the gradient of the line L3. So therefore, our L3 in this case will be y minus 1, change in y, over change in x. X minus 4 is equals to 2 over 3. Is equals to 2 over 3. Equals to 2 over 3. So now, work out this, solve this. X minus the minus comes to plus. So you get y minus 1 all over x plus 4 is equals to 2 over 3. Again, you can multiply both sides by x plus 4. You can multiply both sides by x plus 4 and this side by x plus 4 to remove this denominator there. To remove that denominator. So what do you get? Y minus 1 is equals to 2 over 3x plus 8 over 3. Plus 8 over 3. Plus 8 over 3. So find y. Find now y. So we are talking of line L3. Talking of line L3. Line L3. So you can even do it here. Line L3. Line L3. There now. Want the line L3. So our L3, in this case, you have y minus 1 is equals to 2 over 3x plus 8 over 3. Take 1 on this side. This minus 1 on the other side becomes plus. Y is equals to 2 over 3x plus 8 over 3 plus 1. Plus 1. So plus 1. So get 8 over 3. This is 2 that plus this. Plus 1. You get y is equal to 2 over 3x plus 3, 2 over 3. You get like that. So get 2. You get 3, 2 over 3. So that's what you get. This is your R3. Equation R3. Equation R3. Equation R3. So it should be calculated like that. Remember you had your R2 and you have your R1. You now have all the three equations of the straight lines that are required. Then from there, you go to the last question. The coordinates of S. The coordinates of S at which LV intersects L2. The coordinates L3. So L3, where L3 intersects L2. L3 intersects L2. L3 intersects L2. L3 intersects L2. So part C, where L3 intersects L2. So this one is always a simultaneous equation. It's always a simultaneous equation. Can you take your equation L3, which is this one? Y is equals to 2 over 3x plus 3, 2 thirds. And L2 is y equals to minus 3 over 2x plus 3 over 2. So you have to find the coordinates of S, the point of intersection of the two. This one is always a simultaneous equation that you need to solve. And in the simplest way of solving this kind of equation is by substitution, because the two equations are in the form of y equals to mx plus c. Y equals to mx plus c. So therefore you say this one, this y is equal to this one here. You take 2 over 3x plus 3, 2 that is equals to minus 3 over 2x plus 3 over 2. Because the two values of y are equal. So therefore, bring the terms together. Bring this minus 3 over 2 on this side. Take the other, the 3, 2 over 3 on the other side. So 2 over 3x plus 3 over 2x is equals to 3 over 2 minus 3 2 thirds. You can subtract that. So 2 over 3 plus 3 over 2. You get this is 2, 1 over 6x is equals to 3 over 2 minus 3, 2 over 3. This comes to minus 2, 1 over 6. Minus 2, 1 over 6. So therefore, divide both sides by 2, 1 over 6 by 2, 1 over 6. In our case, our x is negative 1. Our value of x, when you divide by 2, 1 over 6, you get that x is equal to negative 1. X is equal to negative 1. X equals to negative 1. So, what is y? Because you have already got the value of x. Y, take one of the equations. You substitute any, either L3 or L2. Let's take L2. Y is equal to minus 3 over 2x plus 3 over 2. Y is equal to minus 3 over 2x plus 3 over 2. Our x is negative 1. Our x is negative 1. So y is equal to negative 3 over 2, bracket negative 1 plus 3 over 2. Minus, now minus, this one comes to positive 3 over 2 plus 3 over 2. This comes to 6 over 2, because the LCM of 2 and 2 is 2. So you add the numerators, 3 plus 3, 6 over 2. You get that is 3. So the value of y is 3. So therefore, coordinates of S. S is x, negative 1, y, 3. X, so x is negative 1, y is 3. And those are the coordinates of S. And that's how to solve that 10 marks question. That 10 marks question on equation of straight line. So therefore, you need to know the concept of perpendicular, parallel lines, and where the line cuts the x-axis. What cuts the x-axis? The value of y is equals to 0. Then you proceed on with that question step by step without skipping any step, and you get that question correctly. So thank you very much for listening to this. Mwalimu Ignatius Wahome, Mathematics on YouTube. Remember to subscribe. Thank you very much. Asante sana. God bless, God bless, God bless.